right, you guys, so here is the factoring part of our test review. I think some of you had different factoring ones. If you just want to do these instead, that will be fine. I felt like these had were a little bit more closely related to what the tests look like. Okay, so what I want you to remember, like for A, is that we have a leading coefficient of 1. This makes it a little bit easier, which means we can use the cross part, but we don't need to use the box part. So what that means is we are looking for two numbers still that add up to be 6, but instead of having to do any multiplying, we're looking for two numbers that need to multiply to be just this number here, 8. Okay, so two numbers that add up to be 6 and multiply together to be 8. I think those are 4 and 2. And the reason why we don't have to use the box is because these are the numbers, and they're both positive, these are the numbers that go directly into our answer. So it would be x plus 4 times x plus 2. Okay? All right, what's next? What's next? Ooh, the next one, what I want you to remember is because this says to factor and then completely. Because you will get some points for factoring it partially by just using the box and the cross, but to factor it completely, you need to realize that each of the coefficients here, each of these numbers, are divisible by 3. So before I even get started, to make it really easy, I'm going to factor out that 3. I'm going to take a 3, put it on the outside of the parentheses. So 3 times what would be 3x squared, so just x squared, that's what's left over. Plus 3 times what is 15x is 5x. And 3 times what is positive 12, that's just going to be plus 4. So now it's going to be a lot easier because now we just need to factor out the inside of the parentheses, and here the coefficient's 1, so we're just looking for two numbers that add up to be 5 and multiply together to be 4. Okay? And those two numbers are 4, positive 4, and positive 1. 4 times 1 is 4. 4 plus 1 is 5. So to be completely factored, you need to have the 3 on the outside, and then it will be x plus 4 and x plus 1. If you did this a long way and you got something else, you should realize it is a factor, but it is not completely factored. And you should see where you can still factor out that 3. It'll probably just be from one of these, but you should still be able to factor out a 3 from there if it's not factored completely. All right, so C is the same. Before we get started, we want to factor out a 2 from everything. Okay, so 2 times what would give me 2x squared? That'd be x squared. 2 times what will give me positive 4x? That's going to be plus 2x. And then 2 times what is 2? That's just going to be plus 1. Okay, so your answer should have a 2 in the front. So we're looking for two numbers that add up to be positive 2 and multiply together to be 1, and that's just going to be 1 and 1. 1 plus 1 is 2, and 1 times 1 is 1. So this is just x plus 1 times x plus 1. And what's cool about this is that x plus 1 and x plus 1 are exactly the same. So we can just make that 2 times x plus 1 squared. Both of those answers would be correct. All right, what's next? Oh, what's next is the difference of squares. The difference of squares. So that's the rule that says if we just have two terms, one term has an x squared, the other one doesn't have, it's the constant, and we're subtracting them, then we can use the difference of squares. And so what that means is step 1, find the square root of the first term Step 2, find the square root of the second term. Okay, and then we just put them in And because it's called the difference, remember the difference of squares? Because we're subtracting right here, that means one's going to be plus, one's going to be minus. So the square root of x squared is just x. Whoops, doesn't look like an x. It's just x, and we have plus the square root of 36 is 6, so plus 6 and minus 6. Okay. So the next one, E, looks pretty ugly, but it's actually not. I'll show you. You know what? Sorry while I erase this, you guys. Think about it this way. Let's make our box. And we're going to put the first term and the last term in the box like we always do. So x squared here. We'll put a squared here. Okay, so check this out. Let me erase this really quick actually. X squared we can make with x, and a squared we can make with a, and let's just make sure that this works out correctly. X times x is x squared, x times a is, if we do it alphabetically, ax, x times a is ax, so we have, so all together we have 2ax, which is what we have here. So we have x squared here, 2ax there, and a squared here. Okay, so factored form of this one would be x plus a times x plus a. Or, look, those are exactly the same. X plus a squared. All right. X squared minus y squared, it's the difference of squares. The square root of x squared is x times x. The square root of y squared is y times y. So it is just x plus y times x minus y. Okay, I am done with these particular questions, but I'm going to also make a bonus video. Actually, I'm going to put I have time on this. I'm going to put a couple more questions on here that I noticed were on the test that weren't quite like here. And one would be, so write this down, make sure you do this. One would be, what if I had x squared plus 5x, and it asks me to factor that. So when you're factoring something, you're looking for something they have common. And if you notice here, x squared is the same as x times x, right? And 5x is the same as 5 times x. So they both have 1x, right, in common. So what I'm going to do is take that blue x on the outside of a set of parentheses, and then on the inside, so this one is that blue x, then what's left over is what goes on the inside, x plus 5. And that's completely factored if you were doing something like this one. So there's something like that. And then there's just one of our old school problems with the box and the cross. And just so you get one more practice with that, let's do 6x squared minus 11x minus 10. You cannot factor out the same number from each number, so I know I'm going to have to do a full-on box and a full-on cross. First term and last term go catty corner, so I know I'm looking for two numbers that multiply together to be negative 60, because I have to multiply those together. Our two diagonals must multiply to be the same thing. And I have to split this up into two different pieces, so I need two numbers that add up to be negative 11. So if two numbers multiply together to be a negative and add up to be a negative, one has to be positive and one has to be negative, and the bigger one's going to be negative. So bigger. So what two numbers are those? My gut reaction is 4 and 15. If I have negative 15 plus 4, I think that's negative 11. And if I have negative 15 times positive 4, that's going to be negative 60. So positive 4, negative 15. So negative, let's do this. Let's put the negative 15x here and the positive, that's a positive 4x there. And let's start with the 15 and the 10, only because what's cool about that is that both the 15 and the 10 have a negative, and they're both divisible by 5, so I can pull that negative out. So negative 5. So negative 5 times what is 15x? That's going to be positive 3x. And negative 5 times what is negative 10? That's just going to be positive 2. And negative 5 times, or I'm sorry, 3, let's do this. 3x times what will be 6x squared, and that's going to be 2x. So in just a normal problem, we're going to get 3x plus 2 times 2x minus 5. Okay, that's going to be the review on the factoring piece, and I'm going to send out a bonus video on just a couple of things that look a little bit harder on the test. If you do that on a separate sheet of paper and turn it in, you will get bonus points back for that.